Good afternoon. Before I gotta start my discussion, I would like to introduce myself. I am Jean Claire Chome, a BS Ed Math 2 student. Our subject for today is trigonometry. But before that, what is trigonometry? Trigonometry is a branch of mathematics concerning the specific function of angles and their application to calculation. There are 6 functions of angle commonly used in trigonometry. Their names are observant, are in like sine, cosine, tangent, cotangent, secant, and cosecant. There are types of triangles according to the kind of angle. The first um, the first angle is the right triangle. This is the example of a right triangle. A right triangle is a triangle with a right angle. It's called right triangle. The second triangle is the oblique triangle. Oblique triangle is a triangle without the right angle. There are also kinds of oblique triangle. The first kind is the acute triangle. Acute triangle is a triangle with 3 acute angles. The next is the obtuse triangle. A triangle with an obtuse angle, and that is the obtuse triangle. There's also a triangle that's called equiangular triangle. Equiangular triangle is look like this. This is a triangle with 3 equal interior angles is called an equiangular triangle. The measure of each interior angle is 60 degrees. If it is measured in 60 degrees, that's what we call equiangular triangle. There is also a kinds of triangle according to the number of congruent sides. The first triangle that has the number of congruent sides is the scalene triangle. This is the figure of the scalene triangle. Scalene triangle is triangle with no 2 sides congruent. There are no 2 sides are congruent. The next example is the isosceles triangle. Isosceles triangle is a triangle with no congruent sides. This is the illustration of the isosceles triangle. This is the third example, the equilateral triangle. It is a triangle with 3 congruent sides. This is the illustration of the equilateral triangle. Equilateral triangle is also an equiangular triangle because it measures 60 degrees of each side. That's why equilateral triangle is also an example of equiangular triangle. Another example also is the isosceles right triangle. Isosceles right triangle is a right triangle with 2 congruent sides. This is the illustration of the isosceles right triangle. This illustration shows that there are 2 congruent sides. Let's proceed to the right triangle definition of the trigonometric function of the acute angle. So, in this case, we're gonna tackle about the SOHCAHTOA. But before that, what is the importance or why we should use SOHCAHTOA? So, this is the importance or this is the helpful fact about the SOHCAHTOA. So, SOHCAHTOA is a helpful mnemonic for remembering the definition of the trigonometric functions. So, these are the sine, cosine, and the tangent. So, SOHCAHTOA helps to remember which trigonometric function to be used to calculate ratios from the right triangle and also to find either the side of length or the angle measurement. In this case, this can be helpful in real world application. Also, it is also very useful for the uh, calculation in our real life problem. For example of that, in search of finding the depth of the ocean, so finding the depth, uh, ang lalim ng karagatan, so, or the height of the skyscraper. So, in finding the height, for example, also finding the height of the flagpole. So, we can use the SOHCAHTOA for that case. So, it is very helpful that we should know about the SOHCAHTOA. Then, first of that, what is SO? The word SOHCAHTOA. So, SOHCAHTOA, we have SOH for the SO. So, CAH for the ka and TOA for the TOA. So, for the understanding of the SOHCAHTOA, further more information. So, SO means, it stands for sine equal to opposite over hypotenuse. So is the meaning of so is sine equal to opposite over hypotenuse. Then the ka in SOHCAHTOA, so ka means cosine equal to adjacent over hypotenuse. Then for the TOA stands for tangent equals to opposite over the adjacent. So in this illustration, we're gonna see about on how to identify the hypotenuse, the opposite, and the adjacent. So this is the long one here. The long straight line here is what we call the hypotenuse. To find the adjacent, or first we're gonna locate the opposite. When you see this one, this one, and the theta, when the theta is here, so the opposite line of it is here. This is what we call the opposite of that theta. So to find, for not us to be confused where is the opposite and the adjacent, we must always look for the theta, the location of theta. Where theta is and here, that's where the adjacent located. So this is the adjacent to the theta and the opposite of the theta. So again, we must always remember that the opposite is the opposite to the angle theta. Then the adjacent is next to the angle theta, just what I said earlier. Then for the hypotenuse, it always is that the long one of that triangle. So we have the example of the SOHCAHTOAs. But first, we should find first the So SOHCAHTOA. First, we're gonna find this one. We have the angle like this. So our opposite value is 2. The adjacent should be 3. The theta, we give the value of 40 degree, and the hypotenuse will be 4. So for the So, the formula of So is sine theta is equal to opposite over hypotenuse. So it goes like this. We have sine, value of 40 degree is, we're gonna use calculator for it. So value is goes, we should input sine 40 equals, we have 0.64. So our value of theta of 40 degree is 0.64 is equal to 2 over 4. Then we should elaborate it more. So to solve it, we should input 0.64 over 1 is equal to 2 multiply by 2 over 4 to find the accurate answer. So it equals to 1 times 4, we have 4. Then 0.64 times 2, we have 1.28. So we should check it first. So we have 0.64 times 2. So we have 1.28 over 4. So 128 over 4 divide 4. 1.28 rather. 1.28 divide 4. We have 0.32 is equal to 0.32. So our sign here is 0.32. The value of sign in this equation is 0.32. So let's do for the example of the SOHCAHTOA finding the ka. So ka na naman. So this is still our problem or figure. So we have still our theta is 40 degree. Then our opposite is 2. The value of our adjacent is 3. Then the value of our hypotenuse is 4. So we have goes like this. The formula of ka is, or it stands for ka is cos or cosine 40 degree is equal to we find the adjacent over hypotenuse. So the adjacent is 3, then the hypotenuse is 4. So it goes like that. Then we should find the value of cos 40 degree. So in finding the cos of 40 degree, we should use calculators. So we have, we should input cos like that. Then input 40. Then close parenthesis, we have like this. So it's 0.76.6. So round off 0.77. So equal to 3 over 4. So to calculate it, we should write this one 0.77 over 1 times 3 over 4. Then equals to 1 times 4, we have 4. Then 0.77 times 3, we have 2.31. So 2.31 divide 4, we have 0.5775. So our cosine here is 0.5775. We should write 0.58. So this is our answer. So let's do for the last equation. We have the TOA. So in TOA, still our figure is this. Our value of our opposite is 2. The value of our theta is 40 degree. Then the value of our adjacent is 3. Then the value of our opposite is 4. So, hypotenuse pala. So, the value of our hypotenuse is 4. Okay. You got me, So, this is the formula of TOA. So, TOA stands for tangent or tan
tan theta is equal to opposite over adjacent. Then we have the equation goes like this. Tan theta is 40 degree is equal to the opposite 2. Then the adjacent over the adjacent is 3. So to find that tan 40 degree, we should calculate. So tan, should put tan tan 40 close parenthesis is equal to 0.39 something. So we have we should but round off, that we call round off. We have 0.84 rather. 84 is equal to 2 over 3. So let's calculate it. 0.84 over 1 times 2 over 3 is equal to 1 times 3. We have 3. Then 0.84 times pala. Times 2, you have 1.68. 1.68. So 1.68 divide 3, we have 0.56. So the value of tan, or in the TOA here, is 0.56. So our tan is equal to 0.56. So this is it.
So that's all. I hope you gained some knowledge about that lesson, and I hope you remember it also. It's gonna be useful for your incoming future. So that's all. Thank you and God bless.